Hello Physics Nation, my name is Nate Larmond and this is the companion video for the exercise called Frames of Reference and Simple Sketching in Inventor. Alright, so kinematics is the study of motion. Our first kinematic model, speed equals distance over time, was used to predict our transit times between classes during our first experiment. Are transit times reasonable? Defining a frame of reference to describe an object's position in space was an idea dreamed up by René Descartes about 400 years ago. Here's the associated website for René Descartes. Another amazing resource is provided by the Physical Science Study Committee, and specifically Professors Hume and Ivy from University of Toronto. It's a really old school video, but click on this hyperlink and check these guys out. They're amazing. Anyway, we're going to examine frames of reference using Inventor, 3D modeling CAD software that also defines space with three mutually perpendicular axes. The purpose of the exercise is to draw and extrude 6 simple shapes in Inventor. Then turn on the visibility of all the reference planes and reference axes in your shapes. You're going to take screen images, snips of your shapes, and you're watching this video right now, obviously. You're going to paste those snips into a Google Doc or a Word document and then upload it to Schoology, our learning platform. Okay, so let's make some shapes. Here's Inventor. Here's our home screen. Let's make a new part. Right-click, New Sketch, and this is what it's all about. This is the purpose of this video. Here's the XY plane. This is the X-axis down here. This is the Y-axis. Here is the YZ plane. Again, the vertical axis is the Y-axis. This one coming off sort of diagonally to the left is the Z-axis. Here is the frame of reference. Here's the whole point. Anyway, the first thing Inventor asks you after you start a new sketch is, what plane would you like to draw this sketch? And I usually do the XY plane. So let's select the XY plane. Now we're in the sketching window. So let's draw some lines. Let's click on this icon up here and sort of go, click, 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 whatever, make some kind of profile, do whatever you want. Let's come on back. So that green snap dot, I don't know what it's officially called, anyway, means you just made a joint, a constraint. There are all sorts of constraints popping up here. Let's finish this sketch. So all we tried to do was connect a bunch of lines by left-clicking, 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 and then you came back to the beginning of your original line and found that green snap and clicked on that. Anyway, let's finish the sketch. Now what we're going to do is extrude it. So left-click on Extrude, and look at that. You can make it a thin section. How about 0.25 inches? And if you press on this little hand and then you click and drag over here, you can pull it over to your model. And we're going to take a little screen snip. Let's see. New screen snip, and here we go. Oh, whoops. No, we're not going to take a screen snip. Sorry, I forgot. We're going to turn on the visibility. So come on to your model. Sorry, let me get out of that. Come onto your model and expand the origin folder. And then you're going to right-click on the YZ and left-click on visibility. Right-click on XZ. Left-click on the visibility. And on down the line. Right-click, left-click. I'd also like you to turn on the visibility of all the reference axes. So we're going to right-click, left-click, right-click, left-click, right-click, left-click. And why not the center point as well? Okay, so we have all our reference planes, they're called. and all our reference axes. They're a little bit hard to see, but if you mouse over them, you get a circle on one end and a circle on the other. So it looks like a little barbell when you mouse over them. All right, thanks for watching. See you in the next shot.